All right, welcome back. This is day two of the 2024 10th annual virtual residency workshop. Excuse me, Tuesday, June 25th, 2024. And leading off this morning is Mike Renfro, who's going to be talking about the cyber infrastructure landscape. So let's welcome Mike and take it away.
All righty. Yep, mute's off. Okay. Hey, I'm Mike, Tennessee Tech University HPC Systems Administrator, and currently on Campus Champions leadership team. Uh, I got basically two sets of slides as per Henry's instructions. One set on, they're all both on the cyber infrastructure landscape. One is on, let's just call it organizations and not stuff. And then the other one on stuff and consulting areas and people that can help you use the stuff, but are a little bit more focused. So, uh, behind every good LinkedIn bio is a shameful past and a reality. And so, to give you a little bit of idea of where I come from on this, you know, you go back far enough and I mark up decades of engineering research support experience, and it really comes down to this. I am, self-diagnosed, high-functioning ADHD guy who should have spent more time studying than he spent helping people in computer labs in the 90s. Okay. And I lucked into a couple of different co-op years at Oak Ridge National Lab doing a mix of CAD support, Unix sysadmin work, and actual engineering. And that kind of split attention has sort of followed me on from there. So now I got 3 degrees from what used to be a large master's program university and is now an increasing R2. I call it a master's in shaking things and a PhD in breaking things. Uh, I have mostly been a solo or very small team practitioner for RCD, first as an R&D engineer in a research center here, and then full-time HPC administrator in central IT for the last 7 years. I'm a member of way too many RCD community groups to pay attention to all of them. I've been on the Campus Champions leadership team for a couple years, and I am a compulsive advice giver and rabbit hole chaser. Uh, and so, for the folks that are either going to get sick of my charming accent or you just don't have a whole lot of time today, I want to start off with what I would call the starter pack of organizations that if you get in and get acquainted with some of these, you will basically have a gateway to anything else that you need to specialize in or find from there. And so the first one is the one that I'm part of leadership team on, that's Campus Champions. This was literally the second group that I joined about 5 years ago, and the one that introduced me to Henry and all the other folks that run virtual residency. It is one of the longest running RCD communities, started around 2008 and formerly funded by NSF's Extreme Science and Engineering Discovery Environment, or EXCEED. We've got about 800 members from all over the U.S., every state, every RCD role, whether that's a facilitator, a software engineer, a system administrator, or whatever. We've got an active mailing list, a pretty active Slack, 2 regularly scheduled Zoom calls every month on Tuesday afternoons. One call of those has a specific topic and an invited speaker, and the other one is just free form, unrecorded community chat over any topic that people want to talk about. So sometimes we'll take something that was recently a hot topic on the mailing list, something from the news, or whatever sort of makes it work for people. One other advantage to Campus Champions, though we no longer have direct ties or funding from EXCEED or the Access follow-up project, the Access team does provide Campus Champions members with extra insight into their institution's usage of various Access resources. And that can help your facilitators or your other people guide those researchers toward more efficient usage of those resources or more suitable locations if they're running into trouble. Another big catch-all group, similar to Campus Champions, is Campus Research Computing Consortium, or CARC. That is a newer group, but it still had, looks like 2018 for most things getting started. CARC has a very comprehensive and established structure of different tracks, interest groups, working groups. These are all ad hoc and community driven. Those tracks tend to have about one Zoom call per month and a whole lot of behind the scenes coordination going on. And the single biggest thing that I will call out and applaud CARC for is for ongoing and honestly invaluable work in professionalization of the RCD field. And that helps, for example, translate RCD roles that are kind of fuzzy and nebulous into job family matrices that I've used here at Tennessee Tech to hopefully hire some people to help me out. And the RCD Nexus organization that puts together workshops and papers on workforce development, on benchmarking your organization against others so you can sort of figure out what to prioritize for improvements. Now, all of those organizations, both of those Campus Champions and CARC, are purely virtual organizations. There is no cost to join. It is an extremely welcoming community and very accessible to all kinds of newcomers. So also, I forgot to mention earlier that all of these slides pretty much will have a QR code on them. So if there's something that piques your interest, then go ahead and snap a picture of it and send it to somebody. Also, once you get the PDF slides, all of those links on the QR codes are also all going to be clickable links. So that way, it makes things a little bit smoother. Okay, so if you're up for some travel and for more traditional conference type environments that happen once a year or so, if you don't know where to go to improve your RCD program, then here's a couple more options. And so the Association for Computing Machinery, the main professional society for computer science, aka ACM, hosts the annual Practical Experiences in Advanced Research Computing, which we just all call PERC. This is by far my top priority conference for the last few years. Okay. This is the de facto RCD conference for the RCD professionals. It's only had about 800 people attend last year. 782 was the exact number. So it's small enough to where you can meet a lot of people from a lot of different places that are doing a lot of similar work to you, but you don't necessarily get overwhelmed by it. This is a somewhat normal academic / professional conference. And so there are paper and presentation tracks. There's a poster session. There's a visualization showcase where people can show things off and you can get ideas to take back with you. There's a full day of workshops and tutorials on just a huge range of topics. There's also usually co-located events, both from CARC and RCD Nexus on the Sunday before the actual conference starts. And so I think I speak for most people when I would say go to PERC at least once. But like I said before, this is on my hot list of travel priorities every single year for the community and the content that goes on there. Now, on the other side of the conferencing spectrum is the Supercomputing Conference Series. This is on the far other end of the spectrum, especially in terms of population. 14,000 attendees in Denver in 2023 last year. Huge vendor and exhibition space compared to PERC. Lots of vendors, lots of recruiting. They have a student cluster competition where teams from literally all over the world will compete to get the most performance out of a cluster on a limited power budget on a range of computational codes. And then also alongside supercomputing, every year they've put together the SciNet local network and wide area network connections. Last year, they put together nearly 7 terabits of wide area network access bandwidth, not counting all the stuff that was inside on the local network. Full disclosure, I have never been to a supercomputing yet, but I am hopefully going to this year's in Atlanta. Now, from what I've heard, a lot of people would say you should go at least once, but don't feel bad if you only want to go once, because it can be a completely, it's a big experience from what I've been told. And so last but not least, more on the virtual side than the physical side in terms of, official annual things that you can go to would be for the virtual residency program that you're already here. Henry has already explained what all of this is about. This is, to me, again, data set of one. This is the best value experience for RCD professionals, not just because it's free, but because it also has high value. Take a large number, divide it by 0, you get an even larger number, I'm told. And so if you're an under-resourced institution or an emerging program, this sort of thing is very high impact, low cost, and absolutely worthwhile. And I thank Henry for getting me into this back in 2019. So after we get through the starter pack, there's dozens, if not hundreds, of other organizations that are RCD specific or RCD adjacent, other conferences, things you can get into. And there's going to be some overlap between them, but they've all got a little bit of different focus, different priorities, different structure. And so, how, especially if you're new to the field, how do you make sense of all of this? How do you direct you or your coworkers to the right ones? And so I'm going to break these up according more or less to Clark's facings terminology. And again, if you've already seen this before, you can take a nap for 30 seconds. And if you're not, facings are basically the broad sort of center part of the bell curves of what people do in different RCD roles. And so your researcher facing folks, for folks that work directly with your researchers, doing onboarding, training, co-creation of research products, data facing for your data librarians, data management focused people, software facing for software development and profiling, systems facing for all of your beloved systems administrators, network engineers, and all those types, and a strategy policy facing area for the folks that deal with the management and leadership, dealing with outside stakeholders and external partnerships. So organizationally, from the researcher facing side, I think one of the highest impact, low cost, low barrier to entry things that you could get into from the researcher facing side is software carpentry. The software carpentry organization has been around for forever in some form or another. They have what I think is some of the best, most widely tested, low barrier to entry training materials and instructor training out there. And so, it pains my wife how little actual training I got in educational theory and pedagogy before they set me in front of a class. I got to correct a little bit of that with carpentry's training in how to deal with cognitive load and not just wing everything like I normally do. And so we've used software carpentry materials for everybody from advanced high school students through our research faculty. Going through their instructor training is absolutely worthwhile. Their core curriculum in software carpentry covers the foundational things. It's not an HPC set of classes, but it sort of helps people get up into HPC environments. So it covers the Unix shell, it covers Git for version control, and it covers a few different options for automated data processing, either in R or Python. And it works on they have materials for every platform, doesn't require, fancy hardware or anything else to conduct one of those. Additionally, and I categorize this on researcher facing, but anybody could use it possibly, is cyber ambassadors. And I skimmed the agenda for this week enough to know that I think Dirk Colbrey, that's the PI of cyber ambassadors, has like 3 sessions this week covering different things. And this was originally an NSF workforce development project for RCD professionals. And so they'll explain what they are in more detail. But in general, Cyber Ambassadors is a recognized leader in training for some more of the soft skills that complement the technical abilities that you or your coworkers have. And so they got workshops in communications, teamwork, and leadership. And last year, Kirk and Kirk's wife, whose name I have forgotten, unfortunately, because I'm a bad person, were brought into the ASEE, the American Society for Engineering Education Hall of Fame last year for their work in cyber ambassadors. So that gives you an idea of the broader recognition that this has got. Going on into the data facing side, there's RDAP, the Research Data Access and Preservation Association. And this is for your research librarians and your data management people, your archivists. And so, I'm the son of a less fancy public school librarian where I went for 13 years from kindergarten through 12th grade. I love being around librarians. I've been to 1 RDAP conference total, but it was a lot. It was great. And so RDAP just finished their annual conference just in the last month or so. And so the QR code that I've got here and the link there will take you to a full set of all of their YouTube recordings, their posters, their slides, their other materials. They absolutely, practice what they preach on FAIR principles. You can trust librarians to do FAIR principles on anything that they do. And so RDAP stuff there is really valuable, and I don't think it really has a peer anywhere else in the RCD ecosystem. Okay, data carpentry. Data carpentry is a sister organization to software carpentry. The whole umbrella is called the Carpentries. And so data carpentry is more domain specific training suited for a variety of physical and social sciences. It has a little bit of overlap with software carpentry materials, but software carpentry is very, very broad based, whereas data carpentry is more domain specific. It can talk about some of the techniques that are specifically relevant to that field. And so you don't burn a whole lot of time on things that are not directly relevant. And so, they've got they got full workshop curricula. I think one of them even amounts to like a full semester class in some bioinformatics techniques. And that extra focus is something that software carpentry is not really equipped to handle, and is why data carpentry it partially exists. And then the third part of the Carpentries organization, also, I'm putting it in the data facing organization, not so much because they have data, well, they do have some data facing materials, but because library carpentry, the third group, is specifically geared for training and outreach to your library and information related communities and professionals. And so they're writing materials to get the librarians familiar with software automation so that they can be the promoters and the evangelists for those tools elsewhere at their institution. And so it's synergistic with the other carpentries areas. It'll help your library staff possibly provide a gateway to you and your RCD professionals, because they may not know where you are, but they absolutely know where the library is. Every researcher on campus will. So moving on to the software-facing role, the predominant organization, at least in the U.S. for this, and in fact, CARC has not exactly outsourced, but they have very close ties, and I think in U.S. RSE, the U.S. Research Software Engineer Association, takes a lot of leadership in this area. So U.S. RSE, community-driven effort, focuses on the increasingly important role of the research software engineer. And so this is a really, really inclusive group where not everybody is expected to be a professional, titled, degreed software engineer, but they are where you want anybody doing software development to be, I think. Okay. There is so much what I call research grade software out there written by the biologists, the chemists, the engineers, the whoever's, and it's just good enough to get their original research project done, but it doesn't necessarily scale up or out. And USRSE can absolutely help people gain the skills and sort of have a safe community to improve things in that. Another thing that USRSE has collaborated with is with another group called the Academic Data Software Alliance. You can get through that QR code there on that link on this page. ADSA and USRSE collaborated on a comprehensive career guidebook covering both data science people and RSEs, and that nicely complements a lot of what CARC is doing for broader RCD professionalization. And so again, if you click on the QR code or snap the QR code there, goes to USRSE, check their resources page, and you will see this giant, beautifully produced PDF that goes over all of that. Now, for my systems facing people, and I do not want to talk smack about any previous hosters of these talks, but I have often sort of had the feeling that the systems people, we're just sort of stuck off in our own little area, and we don't necessarily get a lot of publicity, and a lot of the systems people are perfectly fine with that. But I want y'all and your systems people, or your people who got pressed into systems roles, to know, where they can get some help. And so Campus Champions was my second group to join as an RCD type person. ACM SIG HPC Systems Professionals was the first one. And so How that occurred, I got hired into an enterprise systems administration group in central IT because I had systems administration skills and experience running HPCs at smaller scales here. Okay. And even with that experience, okay, SIG HPC SysPros showed me so much more stuff that I could be doing and let me learn from other people's mistakes and other people's successes that it has greatly leveled me up in all of my system facing roles. Now, I will tell you that if you look at this group visually, this is not a group of a lot of demographic diversity. It is somewhat driven, and again, it's somewhat driven by the population that it's going to pull from. Systems administrators are predominantly folks who look and sometimes sound like me. Okay. But they are extremely welcoming, practically unstumpable on systems related questions. They have a Birds of a Feather session and a social event every year at Perk, a ridiculously active Slack where most of the year round activity occurs. And, these are as much my systems community as my actual coworkers here. And these are the ones who definitely understand the specifics of what I'm going through, versus the broader enterprise folks, which I still value. But it's good to have sometimes that more enclave sort of thing for the specialty. Also for the systems facing people, not so much as a community, but as another way to level up their expertise and bring that back to your university in a very small amount of time is Linux Clusters Institute. I have never attended any of these, but I know that this is regarded as some of the very best training for your systems people to level up on HPC administration. I know that every time there is an LCI workshop hosted wherever it gets done, there will always be a half dozen or more people all joining on to the ACM SIG HPC SysPros Slack basically all at once. Okay. And they stick around. They are, and again, that's a good synergy between those groups. SysPros people sometimes are conducting the LCIs, the LCI workshops. And so, you're not typically going to get this kind of training on LinkedIn or on any of the places where somebody might go and get a course on Windows or Linux administration or from SANS or anything. You need a group like LCI to sort of provide that extra sort of hyper-focused HPC administration stuff for your administrators and for your user community, because you will make a better environment with what you learn from LCI. Now, on the strategy and policy facing side, and for research, computing, and data, I would say that the Coalition for Academic Scientific Computation, or CASC, is the premier group for your strategy and policy facing folks that are focused in RCD. This is the one that has the closest ties to all the federal agencies that drive a lot of our RCD funding and priorities, and it communicates the concerns and needs of the RCD community back toward those agencies so that there's this constant back and forth of trying to head in the same direction. Now, unlike most of the things that I've talked about so far, CASC absolutely does have a membership cost. It's like $4,000 a year, I think. I can't remember if that scales with organization size or not. And I will fully admit, as a reasonably small town boy with delusions of adequacy sometimes, this is not a conference that I am comfortable at, because these to me are the high level people. I like my systems people. I like my facilitators. I'm trying to become a little bit more of a manager type. But again, it's not my comfort zone, but I absolutely do see the value in what CASC does. They have a unique role to fill in the RCD ecosystem, and I am grateful that they're doing what I can't do nearly as well on my own. Another group for strategy and policy facing folks is EDUCAUSE. EDUCAUSE has a research, computing, and data community group. Now, depending on where your background is, you may not have heard of EDUCAUSE if you basically came out of the academic side of research and got into research computing that way. I will guarantee you your central IT organization knows who EDUCAUSE is, and they are probably a member. And so the EDUCAUSE community group for RCD uh, is a little bit farther afield of these other groups in that they also try to address automation and software and IT in the context of the administration of research rather than purely the research itself. But they also provide an interesting niche and occupy that niche between the solely focused RCD groups and more of your enterprise IT people. Some of your enterprise IT people might be more receptive to hearing something that came from an EDUCAUSE than they would from some of us hippies out in the broader RCD community. Another one, or the last one I've got here in the communities, is the Regulated Research Community of Practice, or the RRCOP. And so this is, again, from my experience at least, the best meeting place for folks that are working at sort of the intersection of IT security and cybersecurity and compliance and research. Okay. And those are always going to be at a little bit of a tension. Okay. Because, as everybody knows, the most secure computer is the one that is turned off, encased in concrete, and dumped at the bottom of the ocean. But you can't do computational research on that system. And so, if your institution is just now getting into some more sensitive research areas, maybe you hired in somebody that brought in some early career funding from the DoD or similar. RRCOP can be an invaluable sanity check for your campus if you've never done that kind of work before. And, at times the security people or the compliance people might go overboard, or your research people might go way underboard in what they have to do in an abundance or lack thereof for caution, for risk management, for unknowns. RRCOP has just been extremely helpful in the few times that I've needed something in gathering up the experience of more experienced institutions and what they're doing to secure their regulated data and promote that kind of research in that field. Let me take a look at the chat. Doodly doodly do. Okay, Dana, yes, I have sent Henry my slides. Make it a web page transformation. Yes, all of this is in Markdown/Pandoc, and I should be able to make it into a regular web page, though I just haven't done it before. Cast membership is, yeah, four grand a year, no variation. Yeah, I think it might be talked about a little bit sometime, but definitely no action on it yet. While I recharge, unmute, tell me if you got any questions.
I'm just trying to think of how to convey the highly condensed amount of knowledge and information in the session to more folks around campus in a Google-friendly way. Like, I can't remember which conference that was at, but it was awesome information. That
I
was the
believe we
problem.
will have a
That's the transcript.
transcript, which is
Cool.
probably mostly accurate.
Mhm.
Transcript somewhere, YouTube video, slides or converted slides into HTML. Yeah.
Awesome.
Yes, and also I should have mentioned this before, full credit to all the folks that have done these talks before that I skimmed and or slightly stole a few things from them in the past. So Melissa Cragen, Greta Kellogg, Jacob Paso Tandy, Doug Genowine, I can't remember who else off the top of my head, but I absolutely did not come up with all of this on my own. You know, invaluable having that structure placed out as I rapidly put all these slides together starting this weekend. Okay.
Mike, just
Yep.
I've never been to this conference, but the I believe it's the second US RSC conference is coming up in October, so that could be an
Okay.
interesting one.
Okay. Anything else? All right. Okay. So on to the second part, systems, providers, technologies. If you joined late, I am not going to go over these hilarious slides about how I arrived at where I am now. Get the YouTube or the transcript, or, count yourself lucky that you got here a little bit late. Okay. So So rather than give you a complete rundown of every possible technology, every possible provider, I don't have that much time. I'm surprised I'm as on time as I am right now, actually. So I want to start with basically giving you the tools to find other resources that would be useful in these, especially in the computational systems area. And so, because, depending on you or your user's background, again, I'm always thinking about the under-resourced, the emerging centers, the people who literally got thrown into this job with no prior experience. A lot of this could be overwhelming. And so I don't want you or your users to make a suboptimal choice in a resource that you use, especially if better resources exist. And so we're going to start with some federally funded computational resources, and then you can narrow some things down from there. And so if we start with the National Science Foundation, the successor to the EXCEED program, ACCESS, the Advanced Cyberinfrastructure Coordination Ecosystem Services and Support Project, um, accessci.org, access-ci.org, where I would probably start if you know that you've got somebody that you're not going to be able to meet their need locally for the full set of aspirational research that they want to do, start with the access allocations port. And so whether you can set yourself up some resources possibly, especially if you're a campus champion, or to help facilitate your researchers to get in there. And so they've got these three main panels on their front page. What is an allocation? Which resources do I want to use? How do I get started with setting up a new account? And so And so the first thing Access is going to want to help you sort of narrow things down is a project type. And they don't care about what the field of science is necessarily, but kind of what scale and what end goal do you have on this project that you're trying to support. Okay. And so honestly, out of the four project types that they've got there, I don't think I have ever had a user have to go beyond the first two. Okay. We are not the biggest R1, heaviest computational place. Okay. And so our needs are actually pretty small, which is good because the lower your needs are, the lower the barrier to entry for access to get started on that. And so, explore and discover allocations and projects will work fine for classes and training workshops of any size. It will work for your NSF graduate fellowship recipients. In some of these allocations, they can be the PI if they have a GRFP. Uh, and so, the thing is that sometimes that level of research can overwhelm the local resources, especially of a smaller university. And so explore and discover can be that first stepping stone up into the national scale ecosystems. Access can also accommodate the biggest research activities. And so, all the ones that make international news, black hole imaging, neutrino stuff down at the South Pole, all kind of that stuff is very often facilitated or literally run through access and access adjacent resources. So they cover a wide range of everything. And so, you know, those of you that have been around for more than a couple of years and you remember the EXCEED project and how you got allocations on that one, if you haven't looked in since then, please do. The access allocation process and procedures are a vast improvement over what Exceeds were in terms of barrier to entry, in terms of flexibility, and in terms of responsiveness. And you know, no shade given to Exceed for what it enabled at the time, but Access learned a lot of lessons from Exceed and sort of got to build some things from the ground up without having to sort of maintain legacy continuity anywhere. Okay. And so, in particular, what is really nice with the access procedures right now is your first three sets of allocation tiers have a rolling, you know, constant proposal review cycle, or project review cycle. There is not a deadline at any particular time of the year. They're constantly being looked at. Okay. They also have pretty small justification requirements. Okay. You know, I would say that the explore allocation, you can get away with an abstract of a paper. Okay. You don't get a ton of resources compared to the bigger allocations, but honestly, you probably get a lot of resources compared to what you might be able to offer locally. So don't shy away from the easy ones to get started. Okay. And so another thing that is different on access procedures versus Exceed was generally on Exceed, you could have one project that could use one set of resources for like an entire year, and that was all you were going to get. You could probably get some permission and cancel projects and redo things, but Access has provided so much extra flexibility in terms of when you sign up and get approved for a project, they issue you a set of credits that can be exchanged at all of the resource providers for CPU time, GPU time, storage, anything like that that is a consumable resource at that provider can be exchanged. And if you find out that you picked the wrong resource a couple weeks in, you don't lose your credits. Just, you know, drop down that, just expire that allocation that you've got with the provider, get your other credits back, take them somewhere else. Okay. Very, very low cost, no cost really, other than the resources that you actually use to swap from one to another. And so you can do a lot more exploration. You can have a lot more safety in terms of not having to worry about making a small mistake that jeopardizes a lot of research progress. Um, I'm going to hope that somebody is keeping up with chat if there's something that I desperately need to see or answer, because there's a whole lot of stuff over there right now. And so while you're working on the documentation for the Access project that you want to submit, you can also check out Access's resource catalog. Okay. Now I've counted them up a few times, and depending on how you categorize them, I think the resource catalog has somewhere on the order of 40 different of these resources that are all hidden behind their own little drop downs, links to their user guides and home pages and this, that, and the other. Okay, there is no way that you're going to go through all 40 of those and retain all the information that you need without it being, you know, really tedious and error prone and take a lot of time. Okay, and so Access in the resource catalog provides some nice plain language filters on the left for you to sort of narrow down the things that you're interested in. So if your researcher says, I'm doing TensorFlow, I need GPUs, I'm not even going to think about a CPU only resource, you can click the resource type of GPU compute and it will filter out anything that doesn't offer GPUs. Okay. If you don't care about GPU, you want to leave that to the AI and deep learning and accelerated simulation people because you need to do a different type of research that's not GPU suited, you can click that off and go for something that's CPU, that's a CPU resource. And so once you've got that narrowed down, then you got a smaller list that you can click through. And so, and again, rather than go through all of these, I'm going to give you a survey of some of the newest, maybe the most interesting, although that's going to be a matter of opinion, of the resources that are on the Access list. But absolutely do not just limit yourself to what I talk about here. Look through their filtering options, explore what might work best for you, reach out to other people, either directly at Access or in any of the communities that I talked about earlier for advice if needed. Okay, you are not, absolutely, you are not in this alone. Okay, and so, you know, one of the ones one of the biggest supercomputing centers, if not the biggest, for U.S. academic supercomputing is the Texas Advanced Computing Center at UT Austin, or TAC. Okay, and so they've got a few different systems down there of varying age. I think some are still coming online or haven't been made it, or maybe not going to make it into the access allocation system. Stampede 3 right now is the biggest, fastest thing at TAC that is available through an access allocation. And so this is, again, on my scale, I've got like, a 2-digit number of nodes, about 50. Okay. Stampede 3 on its own has 1,800 nodes, a mix of Intel GPUs, high bandwidth memory for your memory bound stuff. They're claiming like a 2 to 3 performance increase on some of these high bandwidth memory nodes versus their predecessors for no code changes and just better hardware. So high bandwidth memory, Intel GPUs, high speed networking, and they will take a wide range of application scenarios. And so they are ready to take your leadership class, computing program that scales out to 10,000 plus cores. They will also take your smaller jobs. They will also take high throughput computing applications. Stampede 3, I think, launched in late, like November or December 2023. It is obviously the third out of a successful set of Stampede 1 and Stampede 2 installations. And they allocate a lot of resources through access every year to everybody who is outside UT Austin. So another new system that's just come online recently is at the University of Illinois Urbana-Champaign's National Center for Supercomputing Applications, NCSA. Now, and again, opinionated, but to me, NCSA was sort of like the motherland of academic research computing or academic supercomputing. One of my student workers is an intern up there this summer as part of the Access STEP program. Hi, Sharon, if you're on the call. And if you're not, maybe you'll catch the recording. So the new Delta system at NCSA, very GPU heavy. And, it is basically built for any and all accelerated simulations for AI, for deep learning, any kind of application like that. And again, this is not bleeding edge new because there exist 4th generation AMD processors instead of 3rd generation. NVIDIA has come out with another couple of GPU generations. But if you just look at the scale of how broad how broad Delta is, I am absolutely not going to turn down the chance to get a share of 800 A100 GPUs when I've only got at best 20. And so that is a completely different scale than I'm operating in. And again, all of these here, I'm leaving the QR codes in there so you can sort of click when you get the PDFs or snapshot the QRs. All of these provide storage, or you can get a different allocation from Access for storage. So fast scratch, fast project area, everything has 100 gigabit and up networking. These are well-run, top class computing systems for everybody to use. Hi, Sharon. Okay. Little bit older system, Bridges 2 at the Pittsburgh Supercomputing System, the PSC, that is jointly managed between Carnegie Mellon and University of Pittsburgh. Bridges 2 is a long-standing resource that spans over both the Exceed and the Access programs. Bridges 2, as it is, has existed for several years, and it is absolutely not bleeding-edge hardware. But for certain applications, what they call their extreme memory nodes here that have, 4 terabytes of memory attached. I am still sharing, right? Okay, good. Boy, I hope somebody would tell me. 4 terabytes of RAM in a single node. There are applications that's either graph analysis or other things that absolutely will chew up every amount of RAM you hand them. And so I think those nodes may still be the biggest ones that you can find anywhere in Access for, because everybody else that's went bigger tends to go for lower memory. And so Bridges 2 has been an absolutely invaluable go-to resource for when my users outgrow what I can do here. Or in the case last year about this time when a backhoe took out the power center or take out the power to our data center, which then led to a weeks-long storage outage when basically nobody could get anything done on campus and had to go to offsite resources. ACES at Texas A&M. This one is a little bit different setup. This is not raw compute capacity for solving simulations and AI type things at scale. Okay, and so this is a 130 node system, about 12,000 cores. And they've got a mix of AMDs and a few generations of Intels. But really, the main draw of something like ACES is not how many nodes or how many cores. It's this unique, to the access system, pretty unique system of composable accelerator architectures, where they've got a mix of GPUs, they've got a mix of FPGAs, field programmable gate arrays, where some of your researchers that are into that can basically design custom hardware accelerators for part of their research, coprocessors, intelligence. An IPU is an intelligence processing unit that is like super specialty AI equipment. And so most of these are composable, a few aren't. But what the composable ones mean is you can mix and match the composable accelerators onto other nodes that they don't physically sit in. And it all can be one software-defined, flexible instrument, more than we can do typically with our everyday environments, okay? Some of those accelerators can be shared across multiple nodes. It's incredibly flexible. Again, not the most common use cases for most of what my people want to do, but for the people who need it, this is absolutely invaluable to have this resource available for free to researchers via the access facilitation. And so the last access facility or NSF facility I want to talk about, again, I've given you like 3 different places that specialize in compute, one that specializes in composable architecture. And so sometimes, the reason we call it research computing and data rather than high performance computing sometimes is that not all research necessarily needs super high performance. Okay. But it needs computation. It needs infrastructure. It needs to be able to run and be flexible. And sometimes you can't make that work in a purely batch-oriented and Unix shell-oriented HPC environment. Okay. And so Jetstream 2 is a private cloud environment, predominantly at Indiana University with a few satellite areas elsewhere, suited for any on-demand cyber infrastructure needs. Okay, this runs OpenStack virtualization on the back end. You can use it to make a long-running VM for whatever research purposes. And it doesn't matter if those VMs are computationally intensive or not. You can build out your Kubernetes cluster type thing or whatever you need to do to make that research happen. Now, it doesn't mean that you can't do computationally intensive work on Jetstream. It's just that there are other options for that. But if you want to build your own HPC node or set of nodes, that can be facilitated at Jetstream because they've got 128 core AMD AMD servers on the back end. They've got hundreds of A100 GPUs from a few years ago. They've got a 0.5 terabyte to 1 terabyte of RAM per server. They've got 100 gigabit networking between them. And so they are absolutely capable of doing your heavy computational work, but you're going to have to do a little bit of management of the virtual machines to make that happen. And so, also plug for the PERC conference this year and also plug for Jetstream. I'm going to be doing a half-day workshop of Open HPC Beyond the Install Guide. All of that classroom activity or workshop activity is going to be hosted on Jetstream. And if Jetstream did not exist, I probably would not be able to conduct that workshop. And so many, many thanks to the Jetstream folks and others for making that possible for me. So the other main federal agency that I think of at least in terms of heavy scientific computing and scientific research, is the Department of Energy. And it probably is somewhat a factor that Oak Ridge National Lab is like about a 90-minute drive east of me. And I worked there for a couple years as a co-op. And so, Tennessee Tech has a lot of close relationships with ORNL for graduate programs, for collaborative research, other work. And so Oak Ridge is what they call their leadership computing facility, the OLCF, and it's not the only leadership computing facility, but the leadership computing facilities across the various DOE labs are all under the umbrella of what DOE calls the Advanced Scientific Computing Research Arm, or OSCAR. Okay. And so if access might not be the best fit for what you're doing, and especially if there's some DOE interest and alignment in what your research is, absolutely give the OSCAR resources a look, because some of those are, you're talking top 5 scale, sometimes top 1 for top 500 list for compute capacity. There are 4 main ways that you and your researchers can get access into OSCAR resources. Each one of them is kind of focused on a different niche that is of DOE interest. And each one of them can get you access to different facilities. And so there are some trade-offs in there. So the Insight program is hosted out of the Oak Ridge and the Argonne National Labs. This is for open science applications and ones that can scale out to using the majority of a top 10 HPC environment. So they are not as interested in your smaller scale stuff in that program. Doesn't mean they won't talk to you, but the Insight program would not be where you would want to work, because you're competing against other projects that are more in that particular slice of resources they want to allocate for that. The ASCR Leadership Computing Challenge, or the ALCC, unlike the Insight that can be a multi-year award for really big projects, the ALCC is our 1-year awards. And if your research just aligns with a DOE mission, then, or even if it doesn't directly align, but it goes toward the goal of broadening the HPC using or heavy computational using community, people that can make good use of the facilities at either Oak Ridge or Argonne or NERSC at Lawrence Berkeley, ALCC is absolutely interested in that, and it doesn't have to be as big of a scale as the Insight one is. If you've got some tie-in with SBIR or STTR, the technology transfer and small business sorts of things, for like partnerships between universities and startups, ERCAP, the Energy Research Computing Allocations Process, is the one you want to talk to there. That one is exclusively focused at NERSC. And again, it's not just for any SBIR or STTR. It does have to line up with DOE's Office of Science missions, however those are defined. And I've got all the blue text in here is links to each of those programs, so you can have some easier access to it. Okay, so plenty of time. All right, so after we talk about
questions for you in chat.
Yes. Okay. What does open science mean? Somebody can correct me on that, but my assumption on open science is, it doesn't have like an ITAR restriction or anything else that would put it into that regulated research area. So most of what like your traditional engineering and physics and chemistry people are doing is probably open science. Maybe not as much if they're working on like certain aspects of radar, aerospace, or anything that's got like a defense aspect. Vinod, the Open HPC workshop, I'm going to hold off on that until the end if we've got time, because I know you know where to find me. Is that most of what we have? So as a campus champion, it took less than an hour to request and only a few days to get a Discover allocation. That is my experience as well, is that the lower end allocations can practically be next day. And it takes, I would say it takes less than an hour if you've already got a project abstract that you can leverage. QR codes, commentary. Da, 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 Okay. Did anybody have something that I didn't address? Okay. Jacob's answering some things about the conversions between credits and resources, which is completely variable from resource to resource. But you'll end up with more. I want to say more than you can use. Okay. Also, a distinction between open science journals and non-open science paywalls, open source versus proprietary. Yeah. And so, yeah, I'd say more or less, if you can publish, it's probably open science. But definitely it's not going to include, like I said, controlled information like export arms regulations, ITAR, anything like that. And also all the access resources are also open science. So I guess one distinction is there are certain DOE laboratories that deal with weapons, and there are certain DOE laboratories that deal with, energy, and pure science, for lack of a better term. The ones that are dealing with weapons, you're probably not going to see anything about their computer systems for much. Because you have to be working with them, have a clearance and everything else to access those. So any of these tend to be the more open, accessible resources. Okay. All right. So now that we've gotten done talking about the facilities and the hardware, let's talk about a few different people or organizations that either offer services or consultancies, either for free or for pay, dependent. Okay. So multi-tier assistance training and computational help, aka Match Plus. Match Plus is part of Access. Okay. So Access covers a whole lot of things, not just the resources and not just the people running the resources. But Match Plus is a service where, especially for under-resourced research projects or ones that are just now getting beyond the desktop scale and need to go into a bigger compute environment, this can be an absolute lifesaver, or possibly for new users to HPC in general. And so what Match Plus will do is it'll take requests from a researcher, funded or unfunded, that has a need for computational help, and it will then match them up with a student and a mentor for that student to provide that kind of support. And so the time investment for the student and the mentor is, on the order of 3 to 6 months. The student might spend 5 to 10 hours a week. The mentor might spend 2 to 3 hours a week on that. And so for that, they've got different sample application cases or use cases for Match Plus. And so scaling up from a desktop to a smaller HPC scale, identifying bottlenecks and optimizations in a code that might not have mattered until you needed to do 10 times as much processing or 100 times as much processing as you were used to, or just migrating your existing code that is kind of parallel up to an access resource and going through, the hurdles that might be there. The biggest thing on Match Plus, absolutely zero charge to the researcher. Please make use of them. Now, if somebody knows whether or not the mentors or the students are getting paid out of Access, or if this is purely an experiential thing, please throw that in the chat, because I kind of forgot to go look that up. It's valuable experience at a minimum and good for your community, students and or mentors. Now, an extra tier of Match above Match Plus is what they call Match Premier. Match Premier costs. So Match Premier is what you want if you've got institutional support for your project, if you've got startup funding, if you've got direct, research project funds that can be designated toward this. This one and goes with a potentially higher ceiling on what you can get out of it. And so instead of a student and a mentor for a few hours a week, they're going to help you find a consultant, typically academic, for a 6 to 12 month period. They're going to help you arrange payment between you and that consultant. And this can be, critical for projects where, you could say, I'm a new faculty at an R2. I used to be in an army of postdocs. Where are they now? Because we don't have that many at the R2. And so, and the research scientists as well, the smaller institutions are kind of constrained on that. And so a match premier can add that sort of expert assistance that you would get from possibly a postdoc or a research scientist team, on a particular project for the amount of time that you need them, uh, without having to necessarily go and find and continue and have to continually support that staff the whole time. But these are definitely more like, they're definitely paid engagements. And again, QR code. You can talk to Alana Romanella at CU Boulder for more information about that as well. Another area that sometimes can do some on-site consulting or workshop type things to help you out with some things is the Engagement and Performance Operations Center, or the EPOC. Or EPIC. And so, regardless of how you pronounce it, their main consulting focus is on reducing any bottlenecks or performance issues that you might have in data transfer, in network performance, or something similar. Okay, they have a roadside assistance arm that is sort of like reactive troubleshooting of networking problems. They have an application deep dive service that typically I think is an on-site or at least a longer engagement, maybe over Zoom over the course of multiple days. That gives them the time to look more closely at different application workflows, science DMZs if you have them or not, and any other related areas to sort of evaluate bottlenecks and potential capacity issues a little bit more proactively rather than reactively. And then finally, what EPIC provides is a set of network monitoring tools, including NetSage, that can sort of let you, measure and instrument parts of your network to more proactively discover and resolve performance issues before they turn into a critical thing. And so that one is definitely invaluable again, because, you're, especially for smaller institutions, the central IT people that might have to be directly responsible and deeply involved in setting some of these things up. This might be a completely new area for them, and some things that people recommend doing in a purely research and high performance networking environment go against some of the things that you might do on a more enterprise environment. And so EPIC can provide some of that bridge to help people make that jump. So more for your software facing type people, the Science Gateways umbrella, the Science Gateways Community Institute, and the SGX3 Center of Excellence out of San Diego Supercomputing Center. This can be an invaluable research for your software facing folks. And so Science Gateways in general are usually web-based interfaces to various computational resources. They can greatly reduce the barrier to entry for those resources. And so, but you may not have, people that are ready to do the intersection of web development and scientific application development and make those work together. Okay. The people who are good at writing the research code, you probably don't want writing the web front end from a security or performance perspective, and vice versa. You need to have that kind of mix in there to make a good science gateway. And so the Science Gateways people, they have interests in workforce development for your software facing people, broadening the community that uses advanced cyber infrastructure, because a science gateway can be the literal gateway or the first step that somebody takes into using a much bigger system, because the barrier to entry is so much lower. They can provide some expert advice that your software people are running, or problems that they're running into, and they're trying to steer the direction of future software and gateway development practices with the input of the software facing and research software engineer community. Okay, so talked about the hardware resources that you can get access to. We've talked about some different people that you can get access to for consulting type things. And so the last sort of grab bag that I've got is tools, pretty much just software tools that will help especially for emerging programs, but I think they're useful for everybody. It's just, if you've been around for a while, you probably have already seen these. But if it's new, cool, I'm helping. OpenHPC, absolute lifesaver project for me. Okay. OpenHPC provides a completely free and open source suite of components to build HPC architectures with a minimum of effort. Sharon can confirm this one. But I have had every one of my student workers, as soon as they get through some introductory training material, I have them build an open HPC environment with their documentation that's fully functional on a 16 gigabyte laptop. And I think the slowest one out of my three that have tried it had it done within one working day with a little bit of advice and help from me. But especially the 2.0 release, or the 2.x major release, is absolutely rock solid for that. So super easy to get started compared to trying to put all this stuff together by yourself like I used to have to. And so if your HPC environment was sort of a turnkey vendor product, I am not going to name any names, but there are some very well-placed, HPC management companies owned by even bigger companies that a lot of people get started with. And a lot of people don't renew sometimes because the licensing changes, or they've scaled up and they can't necessarily afford the extra license cost. And so if you're going out of support, or you've had issues with certain aspects of expensive cluster management software, OpenHPC can be that new lease on life for that cluster that's going out of support. And it can also let you focus your future budget on things like hardware and people and other tooling, rather than licensing fees for the back-end infrastructure, where you may not be getting as much value as you first thought. And then again, for those areas and those institutions where that makes sense. Okay. And so again, OpenHPC, great resource for, I want to build an HPC, from basically nothing. And as Sharon said, yeah, we've had some governor school kids. They just got, our second years just got done last week. We had them, high school kids, juniors and seniors, over about a 3-week period. Part of what they did was we went through OpenHPC and they built baby HPC environments out of cast-off desktops and managed them. And again, with a good bit of help, but absolutely accessible at that level. OpenXDMod. OpenXDMod is in use at Access. So that's where this screenshot's come from. And you can also you also can, and I will dare say should, self-host it for your environment. Okay. You should have your systems people look into getting OpenXDMod running on your cluster. Okay. Because this is absolutely an invaluable tool, best in class, I would say, for helping quantify your HPC's usage trends and to then communicate that back to researchers, to leadership, or other stakeholders. Now, if you've got accounting logs from Slurm, you can run the saccount command and you can get a giant CSV or pipe delimited file, and you can throw that into a Python script and process it with pandas and slice and dice things any way you want to. And it will take forever, and if you're not a great software developer, like I am not a great software developer, then, you're just going to spin your wheels, and, it's going to be a little bit brittle. And, what you really want is things like, how much usage did I have? What was the spread of usage? Is this faculty who tells me, for example, I'm not getting enough resources, you need to get people off the cluster, and give me more priority. And you can say, first of all, you're using the majority of the cluster. Nobody else is making much of a dent in it at all. I don't have anything else to give you, and here's the graph to prove it. That can change those conversations very rapidly. I had another one where, like, my students aren't getting work done on the HPC. It's too full. I could just show them, the PI, all of the empty space that was at the top of my usage graphs and say, if you want to have a conversation, about how the HPC is slow and your students aren't using it, we can have that conversation. But all of that white space at the top where your students aren't generating usage is places where they're just not submitting work. You know, have whatever conversation we want to have, but let's have it with data. And so this is probably one of the biggest impact tools that can make a smaller or more under-resourced institution look a lot more professional. Totally free, totally open source, long history of development and support, predominantly out of the University of Buffalo. Also, sticking with the software products that all start with the word open, open on demand, predominantly driven out of the Ohio supercomputer system, supercomputer center, not sister. And so this is an absolutely, I don't think there is a comparison tool really for this. That is built to make your HPC more accessible and easier for new users to get into. And honestly, I think your experienced users are probably going to get into it as well. What this gives you is a web-based interface into your HPC users' files, wherever they are. Under this clusters menu at the top would be a web-based secure shell that runs completely inside the browser. So you don't have to worry about VPNs. If your security office says you can't have access to your HPC because you can't do multi-factor, Open On Demand will give you multi-factor before you can get to the HPC, and that might put you in a whole different situation for broadening the access to your resources. It will let you monitor your jobs, like here in this active jobs area in the bottom left. It can facilitate graphical access to your cluster nodes. So if you can basically run graphical applications scheduled on your compute nodes and be able to make that more flexibly accessible to your people. You can also build forms for your users for common things that they need to run. And so it's potentially you could have a form that sets up a Jupyter notebook or sets up a NAMD simulation or something and submits the job based off of a few fill-in parameters that you can validate, rather than having them always have to fill out and create a new shell script every time. I about guarantee you set up Open On Demand, you are going to see more usage and quicker time for people to get a job started compared to the other methods. Okay. All right. Last tool that I've got is SPAC, and this is predominantly for your systems-facing people and possibly your software-facing people if they do software packaging. But again, for the under-resourced institution that doesn't have a whole lot of people, we have SPAC, and that's a package management tool to support a variety of different platforms and environments, different versions, different configurations. If you've got users who say, I want TensorFlow 2.12, I want TensorFlow 2.11, you've got to manage kind of keeping them in separate folders, managing dependencies, maybe conflicts. You don't want to have conflicts. SPAC can give you the tools to manage all of that. This was designed largely out of Lawrence, Berkeley, if I remember right, for large supercomputing centers, but this can scale down to smaller places. Non-destructive, you install a new version to check something out, it will not destroy the other version. You can have optimized builds, different configurations, all coexisting. SPAC normally has a full-day workshop that they offer at every perk. I have not looked for this year, but I bet they're back again. I've been to it. My student Sharon's been to it. Absolutely valuable. Even though all their training material is online, being able to talk to some of the lead developers in person and get some questions answered absolutely boosted us up over where we were going to be. Okay. I am now under a minute to go. Thank you. Thank you, Henry, for putting this on. I don't actually have this on notes anywhere, so I'm going to ramble just a hair, like I haven't already. But the community that I got into partially via virtual residency program 5 years ago has been absolutely, an astonishing group of people to work with. I will always, I will take a bullet for Henry and possibly give one for Henry if necessary, and Kathy and several other people. So questions for the, okay, Henry, we have a break now, right? Or do we?
Yeah, we do. 30
Okay.
minutes. We'll be coming back at quarter till.
Okay. I will hang out for reading chat and any other questions then, and Henry can decide if we record this part or not. But thank you for the opportunity. I'll be around.